All right, so get ready, because we're about to take a deep dive into something you use every day, but probably don't think that much about.
Oh, yeah. What's that?
Separating substances.
Yeah.
We've got this cool science textbook we're looking at, and honestly,
Yeah.
it's kind of crazy how much goes into just getting things apart.
Right.
You know, like, think about how many different ways we have to separate things.
It's true.
Like, you wouldn't use the same method to get the stems out of your blueberries as you would to get salt out of seawater.
Right. Absolutely not. Those are completely different processes.
Exactly. And that's what we're diving into today.
Sounds good.
So let's start with the basics.
Okay.
The textbook calls it hand picking,
Right.
but you probably just call it, picking stuff out.
Yeah, like when you're cleaning rice,
Mm-hmm.
you pick out those little stones or bits of husk by hand.
Oh, yeah, totally.
Yeah.
My grandma used to make me help her clean lentils, and it took forever.
I bet.
But that was hand picking, right?
It sure was. It's a classic method, especially for separating things that look really different from each other.
Makes sense.
And then there's threshing.
Now that sounds a little more intense.
Yeah, it definitely involves a bit more force.
Isn't that where you, whack bundles of wheat to separate the grain?
Exactly. You use force to separate the grain from the stalk.
Wow.
Yeah.
It's amazing how people figured that out.
I know, right? It's all about applying the right amount of pressure.
So we've got picking things out by hand and then using force to separate things.
Yep.
What else is there?
Well, how about using the power of nature?
Oh, like what?
Winnowing.
Wheeling.
Using the wind to blow away lighter stuff.
Oh, yeah, like when farmers separate the chaff from the grain.
Exactly.
I've always wondered how that works. It's like the wind knows which is which.
It all comes down to weight. The lighter stuff gets blown away by the wind while the heavier stuff stays put.
That makes sense.
The textbook actually describes this experiment where you let a mix of sand and sawdust slide off a plate in the wind. And the sawdust blows away because it's lighter,
That's so cool.
leaving the heavier sand behind.
So it's like nature's sieve.
I like that.
Speaking of sieves,
Yeah.
that's got to be one of the most common ways we separate stuff, right?
For sure. It's simple but effective.
Like using a strainer for flour
Exactly.
or separating pebbles from sand at a construction site.
Yep. Sieving is everywhere.
Okay, so we've got separating by hand, by force,
Yes.
by wind,
All right.
and by size.
You got it.
What other methods are out there?
Let's move on to a 3-step process.
Okay.
Sedimentation, decantation, and filtration.
Those sound a bit more technical.
Well, you probably already use them without even realizing it.
Really?
Think about when you wash rice or lentils.
Okay.
You let the dirt settle at the bottom of the bowl
Right.
and then carefully pour out the water.
Yeah.
That's sedimentation and decantation.
Oh.
Sedimentation is when the heavier stuff sinks to the bottom,
Okay.
and decantation is pouring off the liquid without disturbing the sediment.
I see.
And then to get rid of any leftover bits,
Yeah.
you use a strainer, right?
Uh-huh.
That's where filtration comes in.
So filtration is using something like a strainer to trap those solid particles,
Exactly. And let the liquid pass through.
like making tea.
Precisely. You use a strainer to separate the tea leaves from the tea,
That's a perfect example.
right?
So is filtration kind of like a fancier version of sieving?
You could say that, but filtration can be even more precise
How so?
because it can use materials with super tiny pores.
Oh, wow.
So it can separate out even the tiniest particle.
That's pretty amazing.
And it's used in so many ways, like purifying water or clarifying fruit juices.
Huh. So we've covered separating by hand, by force, by wind, by size, and now by using gravity and filters.
That's right.
It's incredible how many different techniques there are.
It is, isn't it?
So what other forces can we use to separate substances?
Well, how about we make something disappear?
Disappear.
Yeah, let's talk about evaporation.
Ooh, that one always seemed like magic to me back in school.
I know what you mean.
Like when you heat salt water and all the water disappears and you're left with just salt?
It's pretty cool, right?
Yeah, it's like, where did the water go?
Well, when you heat a salt solution, the water turns into vapor and escapes,
Oh, I see.
leaving the salt behind.
And this isn't just a science experiment, right?
Nope.
This is how we get salt from seawater,
Exactly.
using the sun's heat to evaporate the water.
It's a natural process that's been used for centuries.
That's incredible.
And then there's condensation.
Condensation.
It's like the opposite of evaporation.
Like those little water droplets that form on the lid when you're boiling something?
You got it.
It's like the water just reappears out of thin air.
Well, not out of thin air, but it does seem like magic.
Right.
Condensation is when water vapor in the air cools down and turns back into liquid water.
So it's this constant back and forth between liquid and vapor.
Exactly.
Okay, so we've talked about hand picking, threshing, winnowing, sieving, sedimentation, decantation, filtration, evaporation, and even condensation.
Wow, that's a lot.
That's quite a few techniques.
It is.
But what if we need to use more than one method?
That's where things get really interesting.
Like how?
Imagine you're trying to separate salt and sand.
You couldn't just pick out the salt by hand.
Nope, those sand grains are way too small.
So what would you do?
Well, the textbook describes a really clever process.
What is it?
First, you dissolve the salt in water.
Okay.
Then you use either decantation or filtration to remove the sand because it doesn't dissolve.
Right.
And finally, you evaporate the water to get your salt back.
Wow, so you use a combination of methods.
Exactly. Each method has its own purpose.
That's like a science puzzle.
I like that analogy.
You have to figure out the right steps to reach the goal.
It's all about strategy.
So there's a lot more thought that goes into these everyday actions than we realize.
Absolutely. And that brings us to another important concept, solubility.
Solubility.
But we'll dive into that in the next part of our deep dive. Welcome back to our deep dive into separating substances.
Now, where were we?
We left off talking about solubility.
Right, solubility. So that's about how much of something can dissolve in like water or another liquid, right?
Exactly. It's all about how well a substance mixes into a liquid.
Okay, so give me an example.
All right, imagine you're making iced tea and you keep adding sugar and stirring it in.
Okay.
At first, all the sugar disappears, right?
Yeah, it dissolves.
But eventually you reach a point where no matter how much you stir, some sugar just stays at the bottom of the glass.
Oh, yeah, I've seen that happen.
That means you've reached saturation.
Saturation.
It means the liquid can't hold any more of the dissolved substance.
So in that case, the iced tea is saturated with sugar.
Precisely. It's reached its limit.
Okay, that makes sense.
Yeah.
So is solubility like a set rule?
What do you mean?
Like, is there a specific amount of every substance that can dissolve in, say, a cup of water?
That's a great question, and the answer is no. Each substance is different.
Right.
Some substances, like sugar, are highly soluble,
Yeah.
meaning a lot of it can dissolve in water before it becomes saturated. But other substances, like salt, are less soluble.
So they reach their saturation point quicker.
Exactly.
Wow, so it's all about the interaction between the substance and the liquid.
It is, and there's another factor that plays a role, too.
What's that?
Temperature.
Oh, yeah. I remember from school that heating things up can make them dissolve faster.
You're absolutely right. Temperature has a big impact on solubility.
And I bet that ties back to what we were discussing earlier about separating salt and sand.
You're catching on.
Remember Pahaley from the textbook?
Yes, Pahaley was trying to recover a large amount of salt.
Right, and she could only get a small amount out.
Exactly. And we were left wondering, why not just use more water?
Yeah, that was my thought.
Yeah.
But now I'm thinking there might be a more scientific approach.
There is, and it involves heat.
Heat.
Heating a solution increases its dissolving power.
Really?
Yeah.
So you can dissolve more stuff in hot water than in cold water?
Generally, yes. For most solids and liquids, that's the case.
So like with Pahaley's salt.
If she heated the water, she could have dissolved more salt before reaching saturation.
So it's like the heat gives the water superpowers.
In a way, yes. Heating increases the energy of the molecules in the water,
Okay.
making them move faster and interact more effectively with the salt.
That's so cool. So if Pahaley wanted to recover more salt, she could have used more water or heated the water.
Exactly. She had options.
But would that work for everything? Does heat always increase solubility?
Another great question. And it's important to remember that science is complex.
Meaning?
While heating generally increases solubility for solids in liquids, it doesn't always work that way with gases.
Oh, interesting. So it's not a one-size-fits-all solution?
Nope. It depends on the specific substance and the liquid you're using.
So we need to understand the properties of what we're working with.
Exactly. That's a key theme we keep coming back to.
It's not just about knowing how to do something, but understanding why it works.
Precisely.
Okay, so we've got all these different methods for separating substances,
Right.
each with its own strengths and weaknesses.
And we've seen how we can combine those methods in clever ways to separate even the most challenging mixtures.
It's like having a toolbox full of different tools,
And we get to choose the right tool for the job.
and knowing how and when to use each tool is crucial.
Exactly.
This has been such an eye-opening conversation.
I agree.
We've gone from simply picking things out by hand to manipulating temperature to boost dissolving power.
And it's all based on understanding the properties of substances.
And that understanding allows us to separate and analyze the world around us.
Precisely. It's all about looking at the world through a scientific lens.
But are we missing something?
What do you mean?
What
Yeah.
about methods that don't rely on heat or filters,
Like what?
like magnets?
Yes,
I'm
magnets.
sure there are even more incredible techniques out there.
You're absolutely right. We've only just scratched the surface of this fascinating field.
So using magnets to separate things is a whole other deep dive.
It definitely is.
Maybe we'll have to explore that another time.
Sounds like a plan.
But for now, let's shift gears a bit
All right.
and talk about those times when separating substances isn't just about practicality, but about revealing something hidden.
Oh, I like where you're going with this.
Welcome back to the deep dive. We've been on this journey of figuring out how to separate all kinds of substances.
Yeah, from the super simple to the more high tech.
Right, and it's not always about just getting things apart, is it?
Nope. Sometimes it's like we're playing detective.
Oh, tell me more about that.
Well, think about a technique like chromatography.
Chromatography, okay.
It's not just about separating stuff, but analyzing it too.
What do you mean?
It's like you're revealing the hidden ingredients of a mixture.
Okay, so give me an example.
Like imagine you have some black ink
Uh-huh.
and you use chromatography to separate it out.
Yeah.
You'll actually see all these different colors that were hidden within that black ink.
Wow, that's so cool.
It's like magic, but it's science.
So it's like taking something that looks simple and realizing it's actually way more complex.
Exactly. And chromatography is used in tons of fields. Well, forensics, for one.
Oh yeah, like in those crime shows where they analyze a tiny speck of dirt.
Exactly. They can use chromatography to figure out where that dirt came from or if it contains any traces of evidence.
That's pretty amazing.
And it's also used in chemistry, medicine, all sorts of areas.
Wow, so separating substances can be about gaining knowledge and insights, not just practicality.
You got it. It's like we're unlocking secrets hidden within mixtures.
So it's like a key to understanding the world around us.
I like that analogy. It's true.
And that's what makes science so fascinating, right?
Absolutely. It's all about exploring and experimenting and pushing the boundaries of what we know.
It makes you realize that even something as simple as filtering coffee or picking out bad berries
Yeah.
is connected to this huge web of scientific knowledge.
It is. We're all scientists in our own way.
I love that idea.
Yeah.
So as we wrap up this deep dive, I want to challenge our listeners.
Okay, what's the challenge?
Take a look around your own life.
Uh-huh.
What examples of separating substances can you find?
Oh, that's a good one.
What methods are being used?
Yeah.
And most importantly, what can you learn from observing those processes?
Keep those minds curious.
Exactly. Ask questions, explore, experiment. The world is full of amazing scientific phenomena just waiting to be discovered.
Often in the most ordinary places.
Well said. Thanks for joining us on this deep dive into the world of separating substances.
It's been a pleasure.
Until next time, keep exploring. And remember, there's always more to learn.